All right, so mode, we want to be in parametric. All right, so like I was saying before. Then y equals, t goes in, I'll just clear all this stuff out of here so I can take it from scratch. So again, the t is this key. All right, the xt theta n key when you're in the parametric mode. So t, now you want some sequence. All right, so you could try the alpha window and use summation and then type in everything there, but like I said, I mean, there's some TI-83s in the class, so I want to do it in a way that everybody can follow. So second stat, you go to math, option 5. Second stat, ops 5. So it's the sum of the sequence, and then you type in the sequence. So 3 over 2 to the n. So we're just using t instead of n. Going from, so with the variable t, going from 1 to t. And then paste. And again, the step defaults to single increments, so single unit increments. So you could change that if you wanted to go by 2s or 10s or whatever, but if you're going by 1s, then you could just leave that blank. All right. So this will get us our partial sums. Go into the table, and now you can see the full list. All right. It's just not overly pretty the way it's written, but it's all there. All right, so the first one is 3/2. 1.5 is 3/2. 2.25 is, what is that, 5/4? Oh no, 7/4. 9/4? Something quarters, whatever. But these are the values consistent with the numbers that we were creating on the fly. So we wouldn't have to actually do that by hand. And if we're looking to see if this set is converging on a particular number, I can scroll down a little bit and see that it doesn't take too long before it hits 3. Or at least it hits something that the calculator is rounding to equal 3. All right, and so we have an idea now that for large values of n, that this is going to converge on the number 3. All right, so then it really begs the question, like, how would I be able to figure this out analytically, rather than relying on the technology? All right, but if I were to put in something like, let me put in something that I know is not going to cut it. Oh, I think the next example. You just insert it. Insert some parentheses. I think it was 3 over 2 to the t power is the next one.
How do you get the sum sequence again?
Second stat, math 5 is the sum. And then second stat, ops 5 is the sequence.
Okay, thank you.
No problem. All right, so I just made a subtle change to the function. Instead of 3 over 2 to the t, I made it 3/2 to the t, which is the next example. I'm just kind of jumping the gun a little bit. If I go into the table here, you could see that the values are getting outrageous pretty quickly. All right, so it looks like it's diverging. And if I only wanted the first 10 values, I can bring it back. But it's getting very large very quickly. And this is consistent with an R value that's greater than 1. All right, so if I have R to the nth power, if the R value is fractional, it'll converge. If the R value is greater than 1, it's not going to converge, it's going to diverge. All right, and so this is something that your calculator can illustrate for you very nicely. It's also something that, like, it's fact-based. So if you recognize it, then you automatically know that it's going to converge or diverge depending on the situation. You wouldn't have to show any work. All right, so that's where knowledge is a good thing.